Okay, so Danilo is going to talk about, with both his hands, about navigating from complexity to observability using OpenTelemetry. Give it up to Danilo, thank you.
Thank you. Thank you, and thank you for staying. So we're so happy to host this meetup in our offices today. My name is Danilo. I joined AWS almost 11 years. It will be 11 years next week. I started as a solution architect. It was a very small team. Then it grew. And in 2014, as Leon just said, Lambda was launched, and that's one of the reasons why I stayed so many years. I really am passionate about this kind of dynamic serverless architecture. But today, I would like to welcome you into something different. I would like to do a journey with you, starting with complexity and going from complexity into something that is easier to manage, something that we can work and understand in our daily business. And the solution is already there as the last word. It will be OpenTelemetry. So what do I mean by complexity? So let's start to introduce the team. So let's say that we have a problem, like we want to explore a very large and complex landscape. And we want to build something to explore this landscape and maybe find some food. What can we do? Maybe we can build a very sophisticated robot, use one of the most advanced machine learning model that we see are launching today, and maybe this robot can go there and find the food for us. But what is the natural solution to the same problem? What has nature evolved in these millions and billions of years? Ants. A very different solution to find food. And we probably experienced that maybe in our houses. So this is a simulation that is an open source program simulation from a Danish developer. And let's imagine that this is the landscape that we want to explore. The brown circle is where the ants are. And the ants, they are going to look for the food, that is these green dots. And ants, they do something very simple. A single ant will just move around randomly, leave a trace to be able to come back. And if they find some food, we'll leave a different trace to tell to the other ants, hey, there's something interesting on this path. And then randomly, some ants will find the first food, will create this path, and all the other ants will follow the path. So the behavior of a single ant, it's incredibly simple and easy to understand. Move randomly, leave a trace to be able to come back, and leave a trace if I find something interesting. But the collective behavior of all the ants together is impossible to predict if you only look at one ant. You need to look them work together. This is an example of complexity, and it's an example of from a simple component, we have the emergence of a complex behavior that is impossible to predict looking only at a single component. And this is something that in the last 20 years has been studied across all different fields: physics, mathematics, biology, social science. And we found that everywhere, if we have simple components that interact with each other in some simple way, this can be the emergence of something completely unexpected. And this is good for the ants. It's less good for our software, because if we think of our software, each line of our programs is very easy to predict. We know what it does. But when all the lines work together, we sometimes have some unexpected behavior, and we call it a bug, another insect, but that's another story. And that's one of the reasons why we're seeing that many customers, again, probably in the last 20 years, are taking this large monolithic application and they are decomposing into smaller and smaller components. There are other reasons like team structure, team communication, but also that a large piece of software creates these side effects that is impossible to predict and are very difficult to predict when you want to add more features and more functionalities. And this is also the way we work inside AWS. This is a little bit of an overview of the internal architecture of Amazon SQS, a simple queue service. It's a service that you can use to send asynchronously messages using a message queue. Anybody here using SQS? Okay. So internally, we have a front-end service that is, as you can expect, the part that gets the request, create a queue, send a message, receive messages, and so on. This front-end service is talking to a back-end service that is a sort of two-level services, because it's a big container that contains inside other smaller services that are the clusters. These clusters store the messages for the message queue. And a message queue can have one or more clusters, depending on the volumes, and that's the reason why SQS can scale almost without limit, because it fits in, we can just add more clusters. There is a metadata service that is looking at this configuration and storing on a DynamoDB table. This message queue is using at this moment this number of clusters. And then there is a load manager that is behind the scene. Nobody talks to this service, but it looks at the configuration, it looks at the load of the queues, and if needed, will create more clusters for a queue and update the configuration on the metadata service. So this is how it works. And some years ago, one of our engineering team turned out to have an idea to store messages inside these clusters in a completely different way. So change the way we store data on a live system that normally has millions and millions of messages running away at any moment in time. So how can we change this storage without affecting all the customers using SQS? Well, it turned out that it was relatively easy because we were using this microservices architecture with very clear boundaries. So they say, let's create the new cluster that talks outside with the rest of the backend exactly like the other clusters. So we can mix and match them, and the backend service just looks at clusters, doesn't know how internally we store messages. Also, SQS can store messages for up to 14 days. So what we did, we started at some point to say to the load manager, all new clusters now should be created with the new format. And then we started a batch to say all the old cluster for over a period of time were marked as read-only. At that point, when we were read-only, the load manager would automatically create a new cluster that was in the new format to receive the messages. And then after 14 days, all the old clusters would be empty because the new messages were going to the new ones. The load manager would just remove them because they don't need it anymore. So the migration here was very easy, changing the data format in production with millions of messages in flight, because we were having clear boundaries at different levels to limit the propagation of this bug, not the insets, but the software effect. And this is actually how the world works. In the 70s, John Gall wrote this seminal book about system theory, when he wrote this very empirical law that it's everywhere. A complex system never works from scratch. It works if you start with something simple, and then you add the functionality over time. You can create something complex from scratch and expect that it works as expected. And this is the way we build services also at AWS. When we launched Amazon S3, it's the first service, it was 2006. In the press release, we wrote, we are building something intentionally minimal in feature set, because the focus was on building something simple and robust. And then over time, we added many features to S3. And in fact, when it was launched, it was 8 microservices, and now it's hundreds of microservices working together to produce everything that you use today. So having multiple microservices working together is good because you can decompose a complex problem into simple parts that interact with each other. But then I found this interesting conversation between one of our serverless hero and one of our principal engineers. They were saying, often when I talk to people, they look at a modular architecture. This is a serverless architecture using multiple Lambda functions and DynamoDB tables. And they say, oh, this architecture is complex. The same architecture running on servers or containers is much simple. But actually, you're just hiding the logic inside a box. The logic is still there. Actually, probably if you need to talk to a stakeholder, even a non-technical one, it's much easier to talk on the serverless architecture to reason on the components than on the serverless full architecture. But there is always a but. There's some responsibility there. If I build that serverless architecture and I have a problem, I need a way to find where the problem is. Of course, it's a little bit more difficult than with a single server. So that means that when we build this new modern distributed architecture, we don't have to build something that is like a lot of black boxes talking to each other. We need to think how we can properly instrument this application so that if there is a problem, and as we know, there will be a problem at some point, we are able to find where it is and have the information to troubleshoot quickly. And that's the basis of how observability instrumentation work. So this is a few definitions that are here. So observability, I like this definition because it's focused on what it provides. It allows us to reason about systems, even if we don't know how internally they are built, because maybe only a few experienced people know that. But from the outside, we get enough information to reason and query a database to understand what is happening and where is it happening. And to do that, we need instrumentation. Instrumentation is the way these components send signals that can be logs, can be traces, can be metrics that we can correlate with each other and use for our analytics. And we can say that something is properly instrumented when, after an issue, maybe an unknown, we will be able to understand where the problem is in a reasonable time frame. If that doesn't happen, then you probably need to add more instrumentation to your application. And OpenTelemetry helps us because it's an open source framework for instrumenting and processing telemetry data that is creating a standard. So in the past, very few people would invest in instrumenting their own application because instrumentation was vendor specific. If you change vendor or maybe your company merges with another company, then all your investment in instrumentation will be almost lost. You need to rebuild everything from scratch. Now you can use a standard to instrument your application and expect that everything that is compatible with this standard will respect this instrumentation, collect the same signal with the same level of information. So companies can invest time and money on instrumentation. And for me, this is the biggest change that OpenTelemetry brings. So OpenTelemetry is a very popular CNCF project, allows you to instrument once, collect and process these signals, telemetry data, and send it to multiple destinations. It's designed for distributed application and supports 11 programming languages, not all at the same level, but I have to say there's been very good progress in the last year. So what are the important concepts of OpenTelemetry? So first of all, when it started, it was focused on tracing. That was the part that was still missing in many customers. So this is the concept of traces that follow a single request across all the different distributed components of your architecture, and span that isolate and split this trace into multiple components. Then it was added metrics, so you can have a quantitative measurement about something that is happening with your application. Can be CPU usage, can be memory usage, but can also be a business metric, like how many sales per minute I'm doing in my e-commerce platform, how many product searches in my product catalog, and so on. And then now the focus is more on logs. Logs is something that customers already used for many years. So in this case, the interesting part of OpenTelemetry is the new bridge API that tries to bridge the traditional logging framework that customers are already used to the traces and the metrics so that they can be correlated together in an easier way than what happens traditionally. There's also the concept of baggage, the idea of if you have a trace, there's some data that goes across all the span, like the customer ID of a request is the same across all the span, so you can store it as a baggage. And then probably one of the most important things is that OpenTelemetry is also standardizing a protocol to share this information. So all the different vendors don't need to re-implement something from scratch. They can use this standard protocol to receive and send information to an OpenTelemetry source or to an OpenTelemetry source. So let's see how it works in an architecture before looking at more practice in practice with a demo. So if this is your code, your application, you can add OpenTelemetry instrumentation. There are two main ways. There is the automatic instrumentation, where OpenTelemetry will do its best to understand which web framework you're using, which SDKs you're using, and will add some automatic monitoring and signals on top of that. Or manual instrumentation, where you can add your own custom instrumentation specific to maybe the business part of your application, and we'll see the difference. Then the instrumentation will send the signals to the collector. That is a process that can run in the same environment as the application, or for example with container application, it's very common to have it as a sidecar container running inside the same pod or the same task of your application. The collector has a receiver, then there is a processor that can do quite advanced stuff, but normally you don't want to give a lot of CPU and memory to the collector. For this reason, mostly the processor is used for filtering the events and taking only the important ones, and passing to the exporter that can send it to multiple destinations where you can store and analyze this data. We, as AWS, are working with the open source community, and we are contributing to this project. And we also implemented our own open source distribution for OpenTelemetry. It's been up for more than a year now. It's an upstream first distribution. That means that every change that we make, it's passed to the upstream repo before including here in our distribution. But it simplifies the integration with all the different AWS tools. It has a public roadmap. So if you want to know what we are working on inside our OpenTelemetry distribution, or if you want to suggest what we should focus on, this is the roadmap on GitHub. Leave it just a couple of seconds so that I see someone is taking a picture. Also, Google can help you find it relatively quickly if you miss the QR code. And let's see how this works in practice. So let's take a Java application that runs inside a container. So if you want to add auto instrumentation, you can just take the Docker file, and first step is to include the OpenTelemetry agent. This is the AWS distribution. So you add it to the Docker. Then you, in case of anything running in a Java virtual machine, you can use the Java agent parameter to pass the OpenTelemetry agent to the JVM, and it will try to use this to discover the architecture, the SDKs and the frameworks of your application, and it will use advanced techniques to inject its code and collect the information in a relatively transparent way for your application. And then there are a few other environment variables that you can use to configure the name of your application or how often the data should be sent to the collector. This is the auto instrumentation part. As I said, custom instrumentation I think is very important. It's where now we can invest time and money. So for example, if I have an e-commerce platform, what are the two main indicators that the e-commerce is running? Is the CPU usage? Is the memory usage? Probably not. Is the number of orders per minute that my platform is doing? Is the number of product search on my product catalog per minute? If I see that these two indicators are going well, probably my business is okay. If I see these two indicators in my dashboard going not as expected, then probably there is a problem. So to do that, I have to look into my application and look for the business part of my application. And for example, I can add custom metrics or custom traces. So let's say that there is this important method in my business class. To do custom instrumentation, I need to explicitly import the OpenTelemetry SDK in my application. And then for languages like Java and Python that have annotations or decorators, it's relatively easy because I can use, for example, in Java, this annotation with span that I put in, before a method, and automatically this method will now create a span inside a trace. And if I want to store the value that are passed as parameter to the method, I can use the span attribute annotation to do the same. So it's very easy to do that. Other languages, it's a little bit more complex, but Java and Python are very, very easy to do. Once you instrument it, as I said, you can send it to almost any vendor now supports OpenTelemetry. These are the main partners that we have in this space. And let's have a quick look with a demo that I recorded, so we'll probably be on time. And when I was doing the demo, I said, what can I show? And there is, since I was a child, I always liked the guess the number application. When I was to learn BASIC, or more recently when I was learning Rust, I always liked to build the guess the number application, where you generate a random number, you have to guess this number with a few questions, because it's a way to test a few features. I said, okay, let's do this, but what happens if I want to run a scalable multi-tenant version of the guess the number application? Well, if I want to build it, probably I have a user that connects maybe to an internet browser. Then there is some compute platform where my business logic that checks if the number is correct or not, generates the random number, works. This compute platform has a database to persist the different multi-tenant games that can happen at the same time. And then maybe I want to add a message queue to send a message in case there is a winner that then I can process and maybe send update a leaderboard or send some gift. So on AWS, I can use, for example, DynamoDB For the database, I can use SQS, the service that I mentioned before for the message queue. For the compute platform, there are quite a few options. So for example, I can use AppRunner. That is a platform where I can send my code or a container image, and it will automatically scale a web application and manage the availability and the scalability for me. I can run it as a container using ECS, not the platform that we launched. It was even before Docker Compose, and also with Elastic Kubernetes if you want to use a Kubernetes platform. Or I can use Lambda, the service that has been mentioned a few times this evening, and run it as a serverless function. So let's see what's the difference. And this is the interesting part because I need to show it. Let me just check that I have somewhere the arrow. Okay, it should work. Let's hope that it works. Okay, this is the video. I'll try to do it fast so that I don't need to break it, to stop it. So this is the code of my application. I use Python Flask here. And these are the Python route of my application. So /game and ID, it's where I can react with my application. In the Docker file, I have my requirements. I install the requirements. Then I bootstrap OpenTelemetry. And then I run OpenTelemetry with a few environment variables to instrument my Flask application. So instrument is like a wrapper for Python. This is on AppRunner. So I can play the game on AppRunner. Too small, too high, too big, too small. It's always there is not difficult to guess perfect strategy for the game. We go on SQS and we receive the message. I won in 6 attempts. And now let's go on CloudWatch, our monitoring platform, and let's look at the architecture. So as you see, there is SQS and all the services is automatically discovered. Here, if I go on SQS, I can find the trace of the winning path, and I have some information. So I guess the number is using DynamoDB, SQS, so the trace is telling me something. There's some information automatically populated by OpenTelemetry, but there's no link between the business part of my application and the telemetry data. So to improve that, let's add custom instrumentation. So this is the same application. I only import explicitly OpenTelemetry trace and metrics. I create a tracer for the traces and a meter for the metrics. Then I create a few counters, so how many games, how many attempts, how many games have been won. And then now I can use these decorators in Python, for example, to decorate the business methods of my application. So if a game is created, I create a new span, and then I get the span and I add more custom information. What's the ID of the game, for example? I can set some specific metadata for my business application. I can use the explicit with syntax in Python and create another span for the getGame function and set more attributes. And so on, all the business component of my architecture, I added a trace. So now let's play again the game with this new version. 37 is too big, too big, too big, it's very small. 26 is correct. If I go on SQS, I still have the message here that I delete. And now let's go back on CloudWatch. Let's look at the service map. It's the same. I click on SQS, and when I go on SQS, you can find that now I have 2 traces. The first traces is the new one, and now I have all the span that tells me this happened in the get game, this happened in the win game. And if I go in the metadata, I can find all the metadata that I added. So this is the specific game ID where I was when this trace happened. So I have much more information linking the infrastructure and what is happening in my application with the business part of application. This is running on container. So here the collector is running on ECS as a sidecar container. No big changes. I can still play and win. I think with ECS I was very fast. Yeah, I remember that. I still received the message, and we can see that I won in 4 attempts. So that was a little bit of luck. And now we can go and see what's different now. So with ECS, as you can see, there's just a different icon. But if I go on SQS, I again have the same information. So once I built my instrumentation, whatever platform I use, I have the same level of information. With ECS, I also did something different. I also sent the metrics, the business metrics that I created, now the number of games, this kind of information. And this was sent as a CloudWatch metric. And this is now automatically creating a custom space where I have the number of games, how many games have been played, how many games have been won. There's also some automatic instrumentation on Flask that is added. And the same data was also sent to Prometheus because I just had to add another destination. And the Prometheus version is storing basically the same metrics here. So I have the number of games, and again, and now here I'm using Grafana in front of Prometheus to basically have the same level of information. Didn't change a line of code, and both work. So this is Lambda. So to make things a little bit more difficult for Lambda, I said, let's break something and see what happens. So I went into the permission of Lambda, and I changed the name of the DynamoDB table that is used to store. So now the Lambda doesn't have the right permission to write on DynamoDB, on the database. I saved the new policy, and let's go on the game and see what happens. So let's, here I have a Lambda URL that gives me a web interface. I click Start Game, nothing happens. So this is the nightmare. What's broken now? How can I debug? So I go here and I see that DynamoDB has a strange color in the diagram. And if I go here, I see that the DynamoDB, there is a 500 response code, actually a 400 from DynamoDB. And this is happening in a create game function. So I immediately know which is the function, the part of my code where the problem is, what's the DynamoDB call. So it's much, much easier to find the problem, where it's happening, what is happening, and maybe link these to logs and find more information. So let's fix things just because I can't go home and see Lambda not working. So I update the Lambda, the name of the DynamoDB table. I play the game again. I don't do that normally for fun. It's just for the test. And as you will see, everything works. And we will get some level of information from CloudWatch. The interesting part is that with Lambda, we get even more information because, as you will see, the trace is also giving me some information, splitting the information of the trace between what is happening in the Lambda platform and that is managed by AWS and what is happening in my code, that is the part that I'm responsible for. As you can see here, there is this separation in the code that is telling me this is Lambda, this is the function, this is the invocation part, and so on. So more information. So this demo that we saw a little bit quicker than I was planning for, but we're a little bit running late, is showing you how same changes in my code run on all the different platforms without big changes. The different platforms provide different level of support as per today to OpenTelemetry. So with AppRunner, you have a single container, and we manage the OTel, the OpenTelemetry agent for you, and we support tracing. With ECS and EKS, with containers, you can do whatever you want, so you have all the level of support. I didn't test logs because that was a little bit experimental for now. And with Lambda, you can use a Lambda layer that you can add to your function that is using the Lambda extension to start a collector that lives with the lifespan of your function run execution environment. And we support both tracing and metrics similar to containers. So if you want to play with this, I can share with you this code, but I expect that you have better games to play. So there's this workshop that we created where you can play with OpenTelemetry and all these technologies. It's very well maintained, so it's a good way to learn more on the observability space, especially with OpenTelemetry. And yeah, that's what I wanted to show. So complexity is part of our world. We cannot change that. Working with smaller components helps for different reasons, but then we need to add more observability. And OpenTelemetry allows us to ask to our boss to invest more on instrumentation because it's something that you do once and you can use it almost everywhere. Thank you.
Grazie mille.
Prego.
A couple of quick questions for Danilo, for anyone? Let's go over here.
Right, so I noticed one thing you showed was that you had instrumentation on a web service. You wonder, how would this look if your architecture included a command line application that then talked to a web service? Because on one hand, it would be nice to have one trade showing the distributed trades, I guess, everything that happened, both in the command line and what that triggered in the web service. But at the same time, exposing your collector does seem like a bit of a security risk.
That's a very good question. So the big problem, especially with tracing and with all this source information, is correlation. And that's where you can find better products. So first of all, if you use OpenTelemetry, you can change the product with the correlation in a much easier way than before. Second, currently there are many technologies that allow us to follow a web path of a request. If the request doesn't come from the same path, it will have a different unique identifier. So you will need to have some way to correlate that. So one way to do that, for example, is the baggage that I mentioned. So you can add, if these two paths needs to be correlated, but one comes from the web, one from a command line, or from something that is completely disconnected, there should be a key that connects them. It could be the customer ID, the order ID. So this can be stored as in the baggage, and then you need to use a database like Prometheus, for example, or the database that allows you to run queries and correlate this information. The more it is, the more can be complex.
Okay, so the idea is that you would want to do this yourself rather than relying on the automatic instrumentation.
Yeah, but normally if you have this kind of setup, you need to run it only once, like you have to set up your own queries to gather the data together, and then when you have this, you can put it into, for example, a Grafana dashboard or something like that. But you need to do that custom.
Right, thanks.
Awesome, excellent. We've got a question at the back there somewhere?
Yeah. Thank you so much for that talk, it was awesome. I have one really quick question. So I really appreciated the demo. I've used OpenTelemetry a little bit, but I've never really used it in CloudWatch. There's a lot of other third-party tools. Do you expect AWS to expand their offering? Because currently the UI is quite clunky. Being nice. Do you expect them to take a lot of that market share from the third-party tools, or do you expect them to work and integrate those third-party tools as they did with maybe Application Composer or something like that?
So for us, the interest is really to supporting OpenTelemetry and customer using OpenTelemetry well, because we understand that it's simplifying the way customers can instrument and analyze the behavior of their application. So that's our focus. As part of our contribution to the open source project, there are of course specific contributions related to AWS tools. So for example, what I used here is the X-ray, sorry it's late, but the emitter of the function. And then there is the interesting part is that to send metrics to CloudWatch is using the embedded metric format. That is a very efficient way to do that through CloudWatch logs. Too late to explain all the details, but it's very efficient and works asynchronously without having to go through the traditional metrics API of CloudWatch. So that's where we want to focus, simplify the integration of the OpenTelemetry frameworks with our tools. But at the same time, you can add another destination. That was the word I was missing.
Brilliant. Danilo, thank you very much.
Thank you.